What's up? So this is a catch-up of all the stuff we've been talking about. We're going to talk about distribution. We're going to talk about solving equations, both like one step and then like two step, and then variables on both sides. I'll also give you a quick refresh on how we graph using the graphing calculator, also just how to graph without a graphing calculator, both y equals mx plus b, and we'll even talk a little bit about standard form when you need to get y by itself in order to graph it. So here we go. Starting with the very first skill, everyone needs to be able to understand how to distribute. It's called distribution. This is a form of multiplication. Whenever you see two things up against each other, for example, like 2x, that means 2 multiplied against whatever x is. So if x is the number 10, this is really 2 times 10, 20. So that's what we're seeing here. -4 is up against this parenthesis, and so we need to understand that this is multiplication. -4 multiply 7 is -28, and then you have an a there as well that's multiplying against 7, so it's also multiplying against our answer here, -28. We're going to multiply next -4 times 8, and that gives you -32. There is no equal sign, so we're not solving anything. There's no way to figure out what a equals here, so these aren't like terms. You cannot put these together. In order to put things together, they have to have the same variable with the same power. So you can try this one, 5 times n, 5 times 10, and just put your answer right here, and I'll check it when we get a chance. So let's talk about another form of multiplication that has the same idea of distribution, but you may have to combine like terms in the end. So let's see, we've got -7 times 6x. -7 times 6 is -42. There's also an x there. Next, we do -7 times 10, and that gives you -70. Now I'm going to stop multiplying, and the 10 that's in the very back is just going to drop down because it's also being added to any like term that we see. And so it looks like -70 and +10, both of those are what we call like terms, so we can simplify this by putting those together. -42x won't change, but -70 plus 10 is -60. These are not like terms, so you cannot put those together. That problem ends right there. So you can try number 4, multiply these and drop 9p down, and then combine any like terms that you have, and then I'll check your answer here in a minute. Alright, so pause the video if you need some time to work those, rewatch it if you have some questions about it, or just raise your hand and I'll be happy to come by and help you with it. The next section is solving. If you notice that the directions in the first section are simplify and the directions in here are solve. The first section does not have an equal sign, so we can't solve or figure out the value of the variable, but if there's an equal separating the left and right side, we actually can solve to see what that is. We had some problems like this yesterday, so let's take a look and see what you get. You have to know the opposites of all the operations. The opposite of adding is subtracting, and the opposite of subtracting is adding. Those are connected as opposite operations. Multiplication and division are also connected as operations, but you need to know that multiplication really comes in the form of being against a variable. For example, 2x or 4b or something like that. So this is some number -7 is 11. If you subtracted 7 from some number to get 11, it must have been bigger than 11 to get that to work out. So let's say the opposite of minus is adding. Let's add over here, and you get +18. 18 minus 7 is 11. So the opposite of that would be if you were adding. Something plus 3 is 23. So we can go back down to see that that number better than 20. 20 plus 3 is 23. So that works. So we come over here and we have forms of multiplication and division. -4b, that's written against each other. Let's take that number and divide it over to the other side. And now you have b equals, and then you can use your calculator if that's outside of your understanding of the multiplication table, which honestly 68 is pretty big, and 4 times 12 is probably the number that most people stop with the multiplication table. 4 times 12 is 48, so this must be bigger than 12. 48 divides by -4 to make -17. So with division, make sure that you divide that negative with it. When you're talking about adding or subtracting, the sign kind of changes, but when you're dividing that number over, that negative needs to go with it. This is a form of division. So that line is the line that you see in the division symbol, and this represents some number divided by some number. So some number divided by 2 is 8. We've cut some number in half to get 8. So we're going to multiply by 2, and that would tell us that P equals 16. 16 divided by 2 is 8. And if that number had been negative, which it's not, but if it had been negative, you would have taken the negative over with it, making your final answer negative, but that's not what the case is here. All right, so let's look at some slightly longer problems, just barely, because this actually has adding, subtracting, and the multiplication division concept going on, and that's why we call this a two-step problem. It takes 2 steps to get the variable by itself. So let's start with like terms. I see a 7 that's a like term with 121, and always take the number that's not by itself. Don't move 121 because it's the last number on a side. You should never move the last number from a side because it's like a seesaw. If one person jumps off, the other person just crashes down really quickly. So the opposite of minus is adding. Got to be really careful and rewrite this as a -8, and then what this gives you is 128. Let's now divide that number over, and like I said, you need to divide the negative over with it. So let's see, what is 128 divided by -8? That comes out to be -16. Final answer, -16. So this problem is a little similar to this one because it's also a two-step, but consider the opposite of adding here to move 7. Don't move 47. It's the last number on a side, and I'll check your work here in a minute. Pause the video so that you can work that problem, and then let me see your work. This is called variables on both sides. You have R on the left and R on the right. You have M on the left and you have M on the right. So we call this variables on both sides. So this does take probably 3, sometimes 4 steps in order to get the variable alone. So you do not put -2r plus 8 together. You do not put r plus 2 together because they're not like terms. So let's take a moment to put together like terms. And I normally start by moving the variable from the right to the left. Currently that r is adding to 2, really because it's positive, that's the main idea. And so I'm going to subtract r and put it under the like term that it goes with. -2 minus 1 is -3r, and then I need to rewrite everything else in the line. Now we need to combine like terms and do the same thing that we did on 9 and what I hope you did on 10. So try to see if you can finish that problem. Try to get r by itself, and then I'll check your work. Pause the video if you'd like to work it, because now we're going to talk a little bit about number 12. When I'm looking at number 12, let me move my face out of the way, the left side doesn't have anything that goes together, but on the right side you have like terms, 7 and 1. So I'm going to go ahead and start by rewriting the left side, and I'm going to make sure I write it perfectly the same, not losing any negatives. The m won't change, but 7 minus 1 makes positive 6. So similar to what I did over here, I want to move that variable on the right over to the left to put those together. I'm trying to put the variables on the left side and all the constants. Constants are numbers that don't have variables. I'm trying to put those on the opposite side. So I'm going to say subtract m. M minus m is 0. And I'm going to subtract it here. So I like to copy everything from left to right. -10. New number here, 3 minus 1 is positive 2m. And now I have a 6 that's left on the right side. So the problem should get slowly and slowly smaller, where you have less and less things, until at the very end you get only m equals and then your value. The next thing is to put my constants together. Again, I do not want to move 6. It's the last number on a side. So I'm going to move the negative 10 to the opposite side. If it's going to the opposite side of the equal sign, I have to do the opposite of what it's doing. It's currently subtracting, so I'm going to add it over here. So again, I start back on the left and I rewrite everything that's left. I have 2m equals, new number here, 16. And then go ahead and finish that off by dividing, and I'll check your work to see if you did it correctly. Let's talk a little bit about graphing. I want you to try 13 and 14 on your own, and I'll check to see how well you understand what I'm talking about when it comes to solving equations with variables on both sides. When you're talking about graphing needs to be understood through a vision of input-output. When you plug in 0 for the x value, it's like you have 0 plus 2. When x is 0, the equation comes out to calculate 2, so 0, 2 is your point that I'm going to put on the y-axis. And this actually happens every single time because when you plug in 0, you always get this number, which we call the y-intercept. Now, if I was to plug in 1, x plus 2 is my equation, I'm plugging in 1 for x, and you get 3. So 1, 3 is a point. I'm going to find 1, go right 1, and go up 3. And now we're starting to see the line form. I plug in 2. 2 plus 2 is 4. So 2, 4 is a point. 2, 4. Now you may notice that it's starting to just go up 1 over 1, and that's the idea of slope. Slope is the value in front of x. So that's kind of a 1x, so that means it's going up 1 and right 1 as many times as you can fit it on the page. Once you find all those points, join them with a line and arrows on each end, because technically this line is extended forever in both directions. Now, whenever you're talking about things that are more difficult, you need to really understand that idea of slope-intercept form. This value is your y-intercept. Like on the last problem, we started at 2 on the y-axis. Now we're starting at negative 5. Negative 5 is down here. This is your y-axis, and this is your x-axis. So if you're using your calculator here, we'll go to y equals, it's the top left button. You can clear out anything that's currently in the calculator, and I'm doing 3 divided by 2. The X button's up here under mode, right here next to the green button, and then it was minus 5. Not negative 5, but minus 5. Hit the trace button, and you end up getting the picture that you want. So just like I was saying, when you plug in 0, you'll calculate negative 5. Now, I like trace over graph because graph only shows you the picture. Trace allows you to put in x values like you saw me doing on the last problem, but it can do the math really quickly. So if I was to do 3 over 2 times 1 minus 5, I would get negative 3.5. That can be kind of difficult to graph, so I may find another point. 2 makes negative 2. So I come over here and I go right 2, down 2, and if you think about the slope here, it's like it went up 3 and then over 2. Okay? So, up 3, 1, 2, 3, right 2. It could do that again. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So these are all the points that you would get if you kept plugging in different values. 4 makes 1. 4, 1 is a point. So you can use the graphing calculator, but once you really understand how this works, it can make graphing much quicker because we're using that idea of slope and y-intercept. So why don't you try 2 on your own, either using the calculator or using the idea of y-intercept and slope. The last one that's a little more challenging is you have to understand solving equations because you have to solve for y in order to get this graph. So I'm going to take a moment to write this off to the side, and I'm going to try to get y by itself. First step is to subtract x from the left to the right. I'm going to rewrite 2y, but these are not like terms, so I just write negative x minus 10. I'm now going to say, well, 2y means it's multiplying. I need to move it to the opposite side, so I need to divide, and I divide it into each part. Y now equals, this number is